Okay, now we are going to talk about increasing function, decreasing function, and constant function, and few other, things in function. So increasing function, function. I mean, increasing function, decreasing functions, they are pretty common sense, right? Let's say, let me give you an example. I'm going to give you a graph. Right? Let's say you have this x and y line. Let's say you have graph that looks like this. All right. Now, let's cut right here because let's say that's the top part. Let's say that's the bottom part. And it was cut here and cut there. Now, what would you say from here to this part? Right? From here to this part. Would you say this is increasing or decreasing? And of course, this is increasing, right? So from here to here, it's an increasing part, increasing function. What about from here to here? That's decreasing part. From here to here, increasing, slightly decreasing, and increasing again, right? So when they say increasing function, of course, this is not just increasing, it's decreasing function. It's partly increasing, partly decreasing, right? So when they say increasing function, they mean something like this, a function that goes up like that, never goes down. I mean, that looks like it's going down. Oh, don't like it. How about that, right? Let's keep going up. That's increasing function. And decreasing function, same thing. It's if you're going down, that decreasing function, right? Decreasing function. So increasing function, decreasing function is pretty easy concept, right? If a function, you have function like this, if it's like going down like that, then that's a decreasing function. Now, what do you think constant function is though? Constant. Constant function. Well, if a function is not increasing or not decreasing, then we call that constant function. It's not that difficult to guess what it looks like. I mean, not going down, not going up, then you go parallel to the x-axis. And let's pretend this is a straight line. You know, straight line is a myth. Never exist, right? I mean, is this straight line? No, obviously not. I mean, who can actually draw a straight line? No one. It only exists in conceptual math world. Think about it. If you draw straight line in a not so flat surface, would you consider that as a straight line? Well, not really. So what's really straight? They say light travels straight. Well, is that really true? I mean, what about black hole? What about huge mass? When you have a huge mass, light even bend. So, as far as I'm concerned, straight line is a myth, never exists. But it only exists in conceptual math world. And let's pretend that this is one of those lines. Straight line parallel to x-axis. That's constant function, right? All right. So this is not too bad. Let's talk about local maximum, local minimum. Can local maximum. local maximum, local minimum. And this is also pretty straightforward concept, I think. Let's say you have a graph, and that graph goes like that. And obviously, you have this maximum point here, and this two minimum point here and here. And this point and this point is called local maximum. And this point and this point is called local minimum. Well, I have just one question. Why would they call this local? Isn't this point higher than this? So shouldn't we say this is just the maximum? What do you think? Well, yes and no, because this is highest point around that area. But what about that point right here? Isn't that higher than that point? So we don't really know how this graph expanded. It might expand even higher, lower, don't know. So this maximum point, this point and this point, in the same way, the minimum point, they are maximum and minimum only around that area, only locally, right? Only around that area, it's a maximum minimum. That's why they call this local maximum and local minimum. And I think this is pretty much common sense. Okay.